we're going to take a tour of the 2D shooter available in the download section. I've installed it, same as the bare bones game, and now I've run it, but instead of coming to a blank screen, I've got this game. I can click to shoot, I can hold WASD to move around, and that's all there is to it. Let's connect another player, which I'm going to do just by opening another window. I've got two of them now. Now I'm playing on the left side. Now I'm playing on the right side. Now I'm shooting one of them with the other. Dies and respawns immediately. It's got a little yellow on-hit effect or some sort of explosion. And that's essentially the whole game. I'm going to do one more fancy thing. I'm going to run one of the bot scripts that comes with Nengi, and in this case is designed for this game, to connect some more players. The use of the bot script, which is fantastic, is a topic for other tutorials. So for now, all we got to know is it's going to connect a bunch of simulated clients to the game. Let's see, I put it on desktop. 2D shooter demo. Bot, maybe? Game bot? There it is. Let me quickly take a look at the bot code, make sure that's not going to do anything too crazy. Alright, this bot code by default, once again, working in bots is a full tutorial, but this thing's going to connect 10 players. That's all I wanted to know. So, it has connected 10 players. I'm going to take a look at the script real quick. It connects 10 players and randomly hits WASD. So it's simulating just if I were to like play here and just mash WASD. See, now I'm moving like they are. So, I show you this to see the game, you know, as if it's being played by some players. I mean, these are some crazy players. But now you can, there's something to shoot at, and you can see the game working some more. Let's change that bot a little bit more. Let's let those bots shoot. I'm not going to give them like aim or anything because that's actual programming. I'm just going to have them, let's see, they're aimed at 0, 0. This is just going to make them all shoot at the top left corner. Alright, bots. Fantastic. There they are, all firing at the top left corner. Some of them hitting each other, some of them respawning. I'm over here on the side, safe for now. So there we can see the game simulated with a bunch of players. I think you can see everything that's happened in the game at this point. You know, you can move around, you can hit each other, things respawn. Let's take a look at the code for this game and talk about Nengi along the way. I'm going to turn off these bots, let them rest. They've all disconnected. So, looking at the code, not the bots. This game was made from the bare bones template, so it began essentially the same, and then I added all the functionality you can see. Let's look at what it is. The game has an entity called example entity, which represents that red dot that we play as. It is here in the server folder. I like to, you don't have to follow this pattern, but what I like to do is I like to write a server-side version of any entity or any message, anything really, and then I have logic that's really just server-side logic, you know, its movement and things about its state, and then I make another entity, a client-side entity, which is a representation of it. Here we'll find it in the client, and there I put the graphical code. You don't have to follow that pattern. In fact, conceivably you could make them the exact same thing, you know, meaning you could write one entity and it had the code for both. Nengi doesn't really get in your way too much. It forces you to make classes because that's what you attach the protocols to. But aside from that, you can do pretty much whatever you want. So let's look at example entity on the server side. Example entity on the server side has a bunch of pretty boring math physics stuff, which I'm not going to cover in detail, but let's just say what it all does. It's got X and Y and hit points. It's got a direction where it's moving, X and Y, has last fired and fire cooldown. In its update loop, called every frame on the server, it moves in the direction where it was headed. Direction X, direction Y, at a certain speed, 200 units. Its position is clamped. It stays in the square of 0 to 800. And then its direction x and y are set to 0, essentially like losing its movement. It's a very crude physics. It has a move function which gets passed a command. The command is something that we actually produced via nengi and we'll look at later. But the command has a W, A, S, and D. I think we can imagine what those are. That set us up for moving in a particular direction. And then it has some math here, which is essentially the mathematics for creating a vector or calculating a unit vector. It might have been better to actually use a vector, like a library, like some sort of function like vector2 in here, but I just did it by hand. But essentially what this does is it turns some direction into a unit vector, and then in the update loop, I guess we move in that direction at a certain speed. Fire seems to take in a bullets, which is an array. So it's putting bullets into some array that was passed to it, a little awkward there. And it's fired in the direction of x and y. It has some math, which is very similar to that unit vector math. Once again, the bullet is just aimed in a direction, or this seems to be what's passed to the constructor of bullet. We can see some nengi at work here. That bullet is added to an instance. It says instance add entity bullet, so that bullet is some type of entity by nengi definition. And then at the end here we have the protocol, which is really the thing that makes this work with nengi, and we can see that out of all this stuff here, the only things listed in the protocol for example entity, which once again is that red dot, that the hero we control, all that's listed in there are x and y. That means that, aside from random stuff that nengi sends for its own reasons, the only thing it sends about this entity are x and y. So this entity has hit points, but it's not sending them to the client. I think we may have noticed that when we played briefly, there's no hit point bars, there's no anything like that. If we wanted hit point bars, we'd have to add HP to one of the things that's networked. In any case, this specific protocol says send x and y as uint16s, which is unsigned 16-bit integer. If you don't know what that is, it doesn't matter too much. Essentially, it's a type of number. Specifically, it's an integer from 0 to 65,535. I hope I said that right. In any case, 16-bit integer. And the interp flag is set on. So x and y are interpolated and they're a number in a certain range. That's what entity is. Let's look at what bullet is, because this thing created bullets. Bullet. Bullet is very similar. It gets created with a reference to the entity that created it. And let's see, travels in a direction, has a duration. So its duration is tracked. That's something new. And then it has a function for seeing if it collides with a player, which I can see here is, once again, didn't use a physics library, just did it all by hand. But this is basically a circle-to-circle collision test, with one of them being 25, or having a radius of 25, and the other one having a radius of 15, which I think if we go look in the graphics code, we'll see that's what they are. That the player, the red dot, is 25, has a radius of 25, and the bullet has a radius of 15. It, once again, is an actual entity, and it is networked the same as the player character, the example entity, just x and y. I see here I used a different type. I used a type number. What's number compared to the other thing before? It's actually total overkill. It's just a really big number. This could also be changed to some smaller number. So we've seen the example entity and the bullet. Let's cruise through the game logic real quick. Here we have game server. This started as the bare bones game server, which just had the boilerplate for things connecting and disconnecting, and some stubbed out code for handling input that came from the clients. This one has gotten considerably longer, although it's not too bad. What was added to it? Well, it's got an array of players and bullets. I think we could see that's all this game really has in it, those players and the bullets. When a client connects, it sets the client's view to a certain area. This is essentially a static rectangle centered at 500, 500 with a, well, I shouldn't say radius, it's a rectangle, but with a half width and a half height of 500, 500. Why is this awkward like this? Why does it say half width, half height? That's my way of strongly announcing to you that the view in the client is centered. It's not a rectangle that starts at its top left corner. It's centered at its center, and thus it expands half width, half height. You know, it's the syntax people use for access line bounding boxes that are like that as well. In any case, so on connect, We set a client view, and then we call the spawn player code. I think we can imagine what that does. It creates example entity, that thing we were looking at earlier. Looks like it does a bunch of other stuff too. It establishes a reference between the client and the entity back and forth, makes the entity spawn in a random position in a 500 by 5 on a from 0 to 500. Adds the entity to our players array, adds the entity to the nengi instance, and then sends a message, this is new, about the identity of this entity to the client. And inside of the message, it seems to have passed the entity ID. We could go into the specifics of that, but I think, let's just say generally, it sends a message to the game client telling it which of the entities on its screen is the one it's controlling. And in the game, let's go look at it real quick. That's in fact used in the game client, we'll see in a moment, to add this yellow circle to the center of the one that's yours, and it doesn't add it to the one that's not yours. So that's effectively what's accomplished with that identity message. Not a big deal for a game like this. Did we even really need that? Pretty important in games where you have a camera that follows the entity, because that's the way of instructing the client of, hey, which one do we follow? Going on with the game code, we have something for remove player, essentially the inverse of spawn player, removes this example entity from our players array and removes it from the instance. You must explicitly remove entities from instances in nengi. When you add an entity to the instance, it's in there forever. Meaning, if its hit points go to 0, nengi doesn't care or know that that means anything with respect to your game. All it does is it makes sure that anything that's on that entity's protocol gets networked if it changes. So if you want the entity to disappear, then you must write your own logic to say, oh, well, my game has hit points, and when hit points are 0, nobody sees this guy anymore, take him out. And that logic, in fact, exists further down if we keep looking. So in the update loop, here's the section that deals with commands. I'm going to skip that because we're going to look at the game client and look at what command the game client actually sends the server to play the game. So we're skipping that for now. But the rest of the game logic essentially is calling the update function on the players, the bullets, and then seeing if the bullets and players collide with each other. If they do, unlike other games, the bullet doesn't disappear. It keeps traveling through the player, and the player loses 4 hit points. That's a pretty awkward code when you think about it. Might play fine, but what if a bullet is traveling through a player and it can hit it every frame? That gets kind of complicated to figure out how many times it's hit the player, how much damage it really does. It really is just a demo game. I wouldn't put that in an actual game. That'd be like the mechanics of maybe a flamethrower in a game, meaning it does damage every frame, and you'd want to calculate that and be more specific. In any case, but looking at that code, we see that that is what it does. It takes 4 hit points from the player, that's the example entity, whenever it's colliding with it, adds a local message. That's going to be some, nengi-related message again, called impact. We'll have to look at what that is, saying the impact location of the bullet. And then if the player's hit points drop to below 0, it adds this flag to player called needs removed. That seems awkward. Why doesn't it just remove it? Well, let's keep reading. After that, there's some somewhat weird code, not that weird by game dev code standards though, where there's a loop, a backwards loop, going through the players array. We have a players and a bullets array, and there's 2 of these loops. One goes backwards through players, one goes backwards through bullets, and they remove the bullets and the players. So I'm sure some people have seen this before and they want to hear about it, but I do have to mention it because otherwise it's just too weird. Why the backwards loops? Well, you can't remove items from an array in JavaScript while going through the array forward, because you mess up the order of the things in the array. So as you keep iterating through the array, things are not what they ought to be. So if you're removing from an array, there's a few ways to do it, but if you're going to do it with a loop, the loop has to go backwards. So that's essentially all this is doing. It's saying, hey, these players up here who were flagged as needs removed because their hit points hit 0, well, now we just go through them and we pull them all out. There's some more logic, which is that the game automatically respawns you when you die. So for each of the ones that needs removed, it calls spawn player again. Spawn player again creates a new entity and also sends a new, which invokes all this. So it's in a random position, it gets added, and you also get a new identity message, meaning the client now knows, oh, I'm now not that other guy who's not even here anymore. I'm this new one. So that's what's happening there. And bullets does something similar, except for bullets, Their logic is based off of bullet duration. So if their duration exceeds the max bullet duration, what is that? Max bullet duration is 0.8, presumably in units of seconds. So the bullets travel for just under a second, and then they just magically disappear, and that's the logic for that. The final line of the update loop down here is calling instance update. Now that would be the nengi instance. What that does is, well, it does essentially everything. Calling instance update on the nengi instance tells nengi to build the snapshot for everything, for all the state that it's got for this frame, and send it to all the connected clients. So this is really the pump, the heart, if you will, of the nengi instance. Let's go look at the client. Actually, let's go look at some of these other things we saw, like impact.js, before we go to the client and then come back and see what these commands are about. So impact. Impact is created at the location of a bullet, or rather, the bullet was past bullet. The impact was past the bullet's location, and I think we can guess from it being called impact what it is. So impact, very simple object. It's just x and y. It's essentially a point. We'll have to go look in the client to see what it does. I mean, we saw in the game, we can guess. It's that yellow explosion thing that happens when you get hit. So now let's move on to the client. Remembering that we're going to have to, we're going to be interested in commands. We're going to be interested in seeing the client-side version of everything we've just seen. The entities, which is the thing called example entity and the thing called bullet. We're going to be interested in seeing what impact is on the client. And then we're going to look at these controls and see what that's all about, and then come back to the server and see the server receiving the controls. So here's the game client. This game client is not too far off from the bare bones one. You can still see a lot of the format of the, the boilerplate, which is essentially some sort of weird stuff down here at the bottom, invoking interpolate, and then calling process snapshot in a few ways. And then process snapshot, I claimed earlier, was how your game client really does anything with the server's logic. And there's 6 types of messages in here, things about entities being created, updated, deleted, and then things about messages, local messages, and JSON. There's really no JSON being used in this game. JSON's really just a little nicety added to nengi. You can send JSON messages if you want, and they'll come through here. In any case, let's see the create entity logic. It's not in here specifically. It seems to have passed it off to renderer. So it's got a renderer. Let's see, where is it? Called new pixie renderer. And when we receive data about an entity, we call renderer create entity. So let's go look at renderer create entity. So here's a pixie renderer. If you don't know how pixie works, suffice to say, you create this object called a renderer, you add containers to it, and then it automatically renders everything that you've added to those containers. That really is the gist of it. So this pixie constructor sets up that renderer, sets up an initial container. I see I've got some pretty specific logic here. I've created this object called entities, and I've called this array called effects. So let's go look at create entity. Here's the create entity code. It's looking at that which was sent to us from the server, and it says, first thing it does is it checks to see, is the entity the example entity, or is it the bullet? If it's the example entity, it creates its own version of example entity, its client-side version, which we'll look at in a sec. And if it's a bullet, it creates its own version, this client-side version of the bullet. And it adds them in its little, object that's tracking it, the entities, and it adds them to the pixie stage, and that's what, causes it to render. Let's look at the client-side versions of example entity and bullet. So I'm over here in client. I'm going to go to client entity folder. This is something I like to do. I like to make a server-side version of things and a client-side version of things. So example entity, here's some pixie code. Even if you don't know what pixie does, I think you can imagine what this does. It looks like it centers itself, whatever it is, this pixie container, it centers it. Or it moves itself to entity X, entity Y. So whatever we're doing here occurs at the position of that entity. And it's drawing some graphics. This color would be red, FF0000. So it draws a red circle, and then it's got a function called add yellow circle, which I think we know when that's going to occur. That's going to be the function it calls when it decides which entity is us. But essentially, it draws a red circle. Bullet. Oh, I'm on the server side of Bullet. Let's go look at the client side of Bullet. Client side of Bullet is a green circle, 00FF00. And its circle has got a radius of 15. Now, it's a little weird to make a demo that uses Pixie and doesn't have actual, sprites, art in it, and instead uses Pixie graphics. Because Pixie graphics is not what Pixie's really for. It's in there as a nice feature. It's not high performance. So I just do this as a placeholder. If you were going to make a Pixie game or turn this game into something with, more graphics, very easily you just cut out these Pixie graphics and put in your sprites. And there, the game could be fancy, within minutes. So that's all these are. They're a circle. Going back to the Pixie renderer, or because the Pixie renderer seems to handle all of this game's code, let's go find that impact message and the identity message. So here's impact. Impact creates impact effect, which is this code here. Oh, it's a little fancier. It's a yellow circle, FFF, 4 Fs, 2 zeros. And it has an update, and it shrinks itself. So that's what the yellow circle does. It creates a yellow circle that shrinks. So that's what that does. There is one other thing. We wanted to see, we get the message, the identity message. So this identity message, it uses that. And what does it do? Well, it has something called, it creates a reference to my entity. That's just, it says, which entity did you say? Okay, we're going to call that entity whose ID you just sent me. We're going to call that my entity, and to my entity, we're going to add yellow circle. That is how this code over here gets invoked that adds the yellow circle. Where was that? Here it is. So, have we seen the whole game? We've seen all the entities. A red circle that could sometimes have a yellow circle inside of it, a green circle that's a bullet, a yellow circle that's the impact effect. Seems pretty simple. A lot of boilerplate code, somewhat tedious, having two different representations, server and client. Let's go look at the commands that we send from the client to the server, and thus makes the game playable. And we've come full circle, and we've seen at this point, hopefully I've mentioned everything that's in the game. So, command. Let's look at game client actually. So, game client, in its update loop over here, we see that it at some point calls client add command, passes to it controls, and controls is this beastly looking thing. It's an object that's called new player input. Let's go look at it because it's in the command folder. So this is something to know about Nengi commands. Is a Nengi command is just a message. In fact, a lot of things in Nengi are just a message. They have different names depending on how you intend to use them. A Nengi command is just a message that goes from the client to the server. They're just all called commands, and the things that go from the server back to the client are just all called messages. This command contains in it this information. WASD, MX, MY, presumably denoting the mouse X and the mouse Y, and mouse down. If we look at the types that I chose for these in Nengi, WASD are all booleans, meaning true or false. MX, MY are a number, a certain integer of overkill size. Mouse down is a boolean. So this tells us if we're holding those keys down, it tells us if we're holding the mouse button down, and it tells us where the mouse is on the screen. How did we make this? Because we can see what it has, and we can see it being sent. How did I actually choose the values for it? That is in this little input system code, not related to Nengi. This is entirely this game's own specific logic. And I'm glad I wrote this in a nice, tedious, verbose way now that I'm looking at it. Essentially, it's just using the event listeners from document. For key down, WASD, key up, WASD, mouse move, mouse down, mouse up. One behavior worth mentioning in this, especially if you're going to make a game that has WASD control soon, is that it, using this difference between current state and frame state, and this release keys function, it decides that if you hit WASD at all, then it counts as pressed for a full frame. Because it doesn't release the key till the beginning of the next frame. Why is this important? It's important because if you're sampling controls in a loop and all you ever look at is W being held, and your the loop's spinning at 60 frames per second, it's possible that you hit W just very quickly and you miss some of the data. You miss, like, at the point in time where you're like, oh, is W down? If W is down, send to server, we're holding W. Well, what if at that point in time you've released W already because you hit W very quickly? This ensures a somewhat deterministic model or things where it's like, if you hit W, W is pressed for a frame. It also, if you're holding W and then the next frame begins, W counts as pressed for that frame as well. So maybe, tedious minutia doesn't matter too much, but important for those types of controls. So going back to where this data is actually sent, we saw it here. It creates this player input thing. This data here, WASD, MX and Y mouse down, sends it off once a frame to the server. Let's go back to the server, and then we'll have come full circle to see where we receive that data. So here, in this somewhat odd area, boilerplate code for how Nengi gets commands from its clients, we see at some point it says, is the command's protocol name player input? That's the point in time where it's checking the type. It says, did we get that specific type of thing? Because we might have other kinds of commands. This game only has one, but Sharks.io has 12 different types of commands. It's got things about starting stealth, ending stealth, trying to sprint, choosing your level ups, trying to move. It's got them all broken up into different commands instead of sending one massive object that's got all the state of everything. For this game, one somewhat big object was more appropriate. So what's it do with player input? It passes the command to entity move. That's that thing in example entity that we saw earlier, essentially moving us in a direction, or setting us up to be moved in a direction. And then the update loop was the thing that actually moved us. And then, if mouse was down, it invokes the fire code, which we've already seen. What else is worth mentioning? Well, perhaps a little bit about why this is as weird as it is. Because we see this format of while command, basically while there's a command available from instance get next command, and then the command seems to have some data in it. It seems to have a tick, a client, and then we seem to know what entity it's associated with, not because of the command, but because we explicitly established a relationship between clients and entities up here, where when we created the entity, we said, hey, client, your entity is whatever this entity is we just created, and entity, your client is, vice versa. So they're wired together, and we use that down here to say, oh, that client sent this command? Well, we already know the entity associated with any client. Anytime we reference the client, we reference to its entity, so we're going to call its entity move, its entity fire. So that's how that's wired together. The get next command tries to process, or gives you just whatever the next command is that has yet to be processed. Because the game server is ticking slowly away, this one in particular ticks at 20 times a second, which is one tick every 50 milliseconds. Because of that, at the time that it ticks, there can be numerous commands built up from the client. The client is running at whatever RAF, request animation frame, runs at, which in my case is 60 frames per second, and it was sending data at 60 frames a second. So there are going to be numerous commands, in fact, from even one client on each tick of the server. This is just going through those commands in order and making sure we don't miss any of them, and we're applying we're running some logic based on that. Let's see, is there anything else to mention before finishing off this demo? Now that we've seen everything, let's look at the Nengi config. The Nengi config contains the update rate of the client and server. This is used in some calculations relating to the interpolation, so you do want these to be correct very specifically, or in specific the update rate, you want that to be correct. So if you want to try your game at different rates, 10 ticks per second, or maybe faster, more actiony, 30 per second, be sure that not only do you invoke whatever loop it is at that right rate, you also put it here in the config so that the interpolation code can work with that, because it's very timing specific code, so it needs to know. The most important part of the Nengi config is the protocols. This collection of all of these objects we've seen so far that are used to network the game. So we've seen the example entity, the red circle, the bullet, the green circle, impact, the yellow effect, identity, the message that instructed us which one a particular client was controlling, and the player input, which was the movement data, the mouse information, etc. Whenever you add or create any more objects that have protocols on them, any of the types of things that are networked, you have to add them here. And the nengi config, if we go look at client and server, or rather instance, we can see that it is passed into the constructor. So nengi instance gets the config in its constructor. The same thing applies to the client. This is how these two things can communicate with each other. They each have the same set of protocols, and that's how they know what these messages are. If you were to, for example, be coding away and you define a new entity here on the server and you add it, and you go and you restart the client without the client script having rebuilt it, that protocol would be missing from the client, and the client would no longer understand what the server was saying. Likewise, if you change some code here and you just refresh the client without restarting that server process, there again you'll have a mismatch in the protocols that the two of them have been built. That can occur all the time by accident while you're developing, and it's an easy fix. You just turn them both on and off real quick. In the development environment, in the production environment, that gets more complicated because people's browsers can cache the wrong version of a client, and thus you have to bust their cache before publishing an update to your game, which is something I'll say how to do in a later tutorial. It's not a big deal. But point is, nengi config forms a language for the two, and they are two programs, and this is how they talk to one another. I think I've covered everything. I hope I've covered everything. So from here, you're hopefully ready to look at some of the other videos. There's going to be one about bots, which I alluded to, and get started on a game. Good luck. Thanks for watching.